Right, question 7. So this has given you the power output, and it's also given you a time, okay? And it's asking you for energy output, right? So hopefully you know that the formula that links those things together is that power is the work done or the energy transferred divided by time, okay? Again, we can use the formula triangle to help us to rearrange that if you'd like. Okay, like that. Again, if we cover up E with our thumb, you can see that we need to rearrange to be P times by T. Okay, now we're ready for the substitution, but hopefully we've spotted that it's kilowatts there. Okay, and there's 1,000 watts in a kilowatt, in the same way that there's 1,000 meters in a kilometer. So that's not going to be 47, that's going to be 47,000. Okay, and then we're going to multiply by the time. But again, you know, they're trying to be a bit sneaky here, aren't they? That's in minutes. Okay, so to convert from minutes into seconds, we need to multiply by 60. Okay, if you tap all of that into a calculator, then your calculator should say this. Okay, and you can see that I've put the 1,000 separators in there, okay, to make it easy for the examiner to see that this is 42 million. Okay, so anytime that you've got to write down a lot of zeros, help the examiner out. Okay, take the time to put in those 1,000 separators. Okay, or alternatively, you could write it in standard form, which I think is best in this circumstance, which is 4.2 times 10 to the 7 joules. Okay, so during the 15-minute period, so you know, we're talking about the information from part A is the same, you know, it's the same information as part A. Then this much energy is transferred from the chemical store of the petrol, right? Okay, so if you think about it, you've got the chemical potential energy that's in the petrol store, okay, and then that is being converted into kinetic energy, which is the useful power output of the car. All right, everything else is going to get wasted as so infrared radiation to the surroundings and to the thermal store of the surroundings by conduction and convection, and sound radiation to the surroundings as well, right? Cars aren't particularly efficient machines. Well, internal combustion engine cars aren't particularly efficient machines. So now we've got to work out the efficiency. Okay, how are we going to do that? Well, the efficiency formula is the useful energy output over the total energy input. Okay, and then you can choose whether to multiply by 100 or not. Okay, so you can times by 100 if you wish to turn it into percent. Okay, so the useful energy output we worked out in the previous question, that's 4.2 times by 10 to the 7. Okay, and we're going to divide by the total energy input, which was 2 times by 10 to the 8. Okay, and if you do that, you'll get an and then you've got to multiply by 100 as well, haven't you? Okay, and if you do that, you'll get 21.15%. Okay, but then again, look, we're looking back, 2 significant figures there, all right, and this is 2 significant figures there, so our best answer is 21%, which is 2 significant figures. Or if you chose not to multiply by 100, then it's going to be this unitless quantity 0.12, in which case you don't need any units. Not 0.12, 0.21. Sorry.